Assalamu alaikum students and welcome to the first lecture of AS Chemistry. This is Sir Yasin. Let's study chemistry. Now at first, welcome to A-Levels. This is going to be a new journey for you. And in these lectures for AS Chemistry, we will be dealing with all the necessary concepts of AS Chemistry along with the help of various past paper questions. That is going to help you excel in your AS and A2 chemistry and for score an A star. Because A level chemistry is without a doubt a tougher one. But then again, it's even more scoring than being the tougher part. So you can score an A or A star very easily if you stay intact and follow me on Slate. So let's talk about the first chapter of AS chemistry, which is atomic structure. As the name goes, very basic. But then again, there needs to be some spices of A-Levels in every chapter of AS chemistry. So, atomic structure, let's see the learning outcomes. Understand that atoms are mostly empty space. Again, a basic definition. Don't worry, they don't ask such questions in A-Levels. Identify and describe protons, neutrons, and electrons in the terms of their relative charges and relative masses. Now, this is something important that has came in the exams. And why is it important? Because it's the exact same thing from the O-Levels. And you can score 3 marks easily in this question. So for this one, if we look at it, we just need to add these values. This was a table that you've studied in O-Levels as well. So particle is proton. We know where proton is. It is inside the nucleus. Then we know where neutron is. It is again inside the nucleus. And this is electron revolving around the nucleus, outside the nucleus. Now, if we talk about the relative masses, first let's talk about the relative charges. Proton is +1. Neutron has no charge. Electron is 0. You know that. We don't need to memorize the exact values of protons, neutrons, and electrons' masses. They are in 10 raised to power -31 and -27 and different decimal place values. You don't need to remember that. But we need to know that the mass of proton and neutron is almost equal. So we call the relative mass 1. This relative does not mean your relative, your papa, your uncle. This means in relation to. So mass of proton in relation to neutron is 1. But the mass of electron, if proton and neutron is 1, mass of electron is 1 divided by 1860. That's 2 less. And it's so less that we say electron has a negligible mass. Almost no mass. And that is why when we define atomic mass or nucleon number. This is the same thing because here we are talking about the number of protons and neutrons. P and N. Why not electron? Because electron has a negligible mass. As I always say to my students, electron here in this part is like a middle child. I am sorry if I am offending those middle children over there. I myself am a middle child. And that is how electron is being neglected by the parents. So here electron is being neglected by us when we talk about atomic mass or nucleon number or nucleons. These are the same things. So here we need to know that the mass of proton and neutron is almost equal. Then we know their charges, we know their masses. Distribution of mass and charge within an atom. We know that if we talk about the distribution of mass and charge, all the mass, if this is the nucleus, all the mass in the nucleus, because proton and neutron has a mass. But when we talk about the charge, nucleus is positively charged and outside the space is negatively charged due to electrons. That's very basic. But now, let's talk about an important concept of A levels, which is an easier one, but the way it is asked. Normally, your first 2 to 3 MCQs are from this particular topic that we are studying right now, a very important P1 topic. So, behavior of particles in an electrical field. For instance, this is basic. You must have studied in your other grades in physics as well. How do particles behave in an electrical field? Like we see here. Behavior of beams of protons, neutrons, electrons in electrical field. What do we see here? That in electrical field, in this particular field, we have negative charge plate on the top and positive plate at the base. So we know very well the neutron goes undeflected. It goes straight. But proton is deflected towards negative plate, right? Because it's positive in charge. An electron is deflected towards the positive plate. We know that's the charge. But if you notice one thing, electron is turning beforehand and proton is turning later. So, how do we study this particular concept? We talk about the angle. This we call as angle of deflection. Now we know that the angle of deflection of proton is lesser and that of electron is higher. Why so? If I have a football in my hand and I have a table tennis ball in my hand, a football and a table tennis ball, I throw both of them and it's windy. Hawa chal rahi hai. Which one will change its path first and which one will change its path more? Obviously, the tennis ball, the table tennis ball, because it's lighter in mass. It's too light that it's deflected by the wind. But football, it is played in windy seasons, it is played in rain. But remember, we don't play table tennis in open fields. We don't play badminton in open because it gets deflected. So that is exactly what's happening here. Since electron has a very small mass, it deflects more. It deflects more and proton deflects lesser. It's something of a little common sense. So what do we understand here? I will briefly write 2 major concepts here that we've studied because that is how they ask the questions in the exam. And we will discuss a few questions right now. So, the direction of deflection. What is it dependent upon? The direction of deflection depends upon the charge. If it's positively charged, it will go towards the negative. Opposite attract. Unlike charges attract each other. Like charges repel each other. Same concept. But, so direction of deflection is dependent on the charge. And angle of deflection. Now that, my students, is dependent on mass. Now what do we understand from this? If you look at the electron, it has more angle of deflection but lesser mass. So, more the mass, lesser the angle. So we are talking about charges and we are talking about the relative masses, the one from this table. So we need to be very particular about that. But what is happening? So let's solve a past paper question here. 2 at least. This one is a little easy one. First, let's talk about an easy one. Beam of charged particles are deflected in an electrical field in identical condition. The angle of deflection of particle is proportional to charge to mass ratio. We know that. We just talked about it. In experiment, Protons are deflected in plus 15. Plus 15, we mean it goes upwards. And particle Y, we don't know anything about particle Y. So we took proton as standard, and it's turning at, not degrees Celsius, sorry. But the other one has a lesser angle than proton. -5. So what do we understand here? If this is going towards, this is proton, so it's going towards the negative plate, this must be something negative because it is going towards positive plate. So what can it be? What could be the composition of particle Y? Remember, it should be something negative, right? That should be the first thing. Same number of protons, same number of electrons. It's neutral, so it's wrong. Same number of less protons, more electrons. That's negative. That can be true. Let's see. If other options are also negative, we need to go into the mass concept. Let's see. 4 protons, 1 electron. It's a +3 charge. Wrong. 4 protons, 3 electrons. +1 charge. This has a -2 charge. This is also wrong. We left with B. Because B has more electrons than protons. B has a negative charge. And we know that it is going in the opposite direction. So iska matlab kya hua? It needs to have a negative charge. We did not have to go into the mass concept here. In this one, no concept of mass is needed because pehle angle matters. Because neutron ka to charge hai nahi, so it's mainly a fight between protons and electrons. But let's move on towards a more technical question here. Again, beam of charged particles in electrical field, the angle of deflection is the same statement. In an experiment, protons are deflected by an angle of +15. Another identical conditions, H2 minus are deflected by ions, are deflected by the angle of what? Y. H2. What is H2? So we will hold on this question for like 2 to 3 minutes and we will revise the concept of isotopes here. What were isotopes? Atoms of the same element having same number of protons but different number of neutrons. Or you can say same atomic number but different atomic mass. We know that. This is something we know already. So in an isotope, remember, if this is an element X, the value we write at the base is the proton number and that's the atomic mass. So this needs to be a different one. For example, let's talk about this very example of H. That's hydrogen here. Hydrogen has 3 isotopes. H11, H12, H13. Since all of them have 1 at the base, we can skip 1 here. But what do we infer from that? What are the number of protons here? 1. Neutrons. If 1 is the mass is P plus N. If mass is 1, proton is 1, then neutron must be 0. So how to calculate the number of neutrons? Atomic mass minus Z, or the number of protons. So 0 neutrons, But we have the same number of protons and electrons in atoms. So electrons are also 1. In this case, 1 proton, but this time 1 neutron. The mass has doubled. But again, 1 electron. Here, 1 proton, 2 neutrons this time, and 1 electron. We will study isotopes in details in the topic of mass spectrometry, because that is very important with isotopes and their relative abundances. Anyhow, so these are the isotopes, and here we write the masses on the top. Although in a periodic table, it's written in the opposite manner. In the periodic table, this is just in periodic table. Atomic number on the top, mass on the base. That's just periodic table. That's not how you're going to write in the exam and not how you're going to get in the exam. So if you notice here, this 2 on the top means atomic mass, but with a negative charge. So how many particles do we have in H2 minus? So it's the ion of this isotope. We have 1 proton, we have 1 neutron, and we have 0 electron. That is something we know. So we need to understand a few things. Now when this particle, a proton, has a deflection of plus 15, and this particular ion is negatively charged, so we know that this will definitely move in the opposite direction. Definitely. So we are going to cancel out both the plus ones. Easy. Now let's talk about the angle. Students, you do not need to calculate the angle somehow. You just need to understand that if it's going to decrease or if it's going to increase. Sorry, decrease, increase. It happens. And if we look at these values, this is half of 15 and this is double of 15, right? So something of that sort is happening. Now we know that when we compare a proton, this is proton, its mass is 1. But here in this case, H2, we have 1 proton and 1 neutron. And what did we see? Protons and neutrons have almost equal mass. So although our negative ion, negative charge decided the direction here, that it must be negative, because positive proton went towards the positive side, right? So in this case, in H2, our mass is doubled. So when the mass is doubled, let's read it again. More the mass, lesser the angle. So if the mass is doubled, the angle is going to be halved. It will be half. So if this is 15, this must be 0.75. 7.5 minus because it's of opposite charge, and 7.5 because the mass is doubled, so the angle is halved. So that is the concept behind it. That is a very commonly asked question in the exam regarding the particles. And if with this question we understand the concept clearly. So students, I hope this helped you a lot for understanding the isotopes. We just revised it. The beams, the particles' behavior. In the next lecture, we are going to talk about the energy level and orbitals, a very important concept of AS chemistry. So thank you so much for being here with me. We will have a lot of fun in AS chemistry. Take care and Allah Hafiz.